Hello everyone, today I'm going to go over this intersection of two linked list problem. So, uh, so let me try to understand the problem. So, given that the heads of two singular linked lists, head A and head B, return the node at which two lists intersect. If the two linked lists have no intersection at all, return null. So based on the first sentence, we could see that our input is two heads, and then we will return the node where two lists intersect. And let's go through some example to fully make sure that we understand the problem. For example, the following two linked lists begin to intersect at node C1. So given the head A1 and given the head B1, we find that C1 they intersect. So the test cases are generally such that there are no circles anywhere in the entire linked list. No circles, no cycles. So that's a good thing. And so the linked list must return their original structure. So you are not going to change the structure. So this 41845, but here although 1 and 1 is the same, but they are not on the same linked list. They are intersect at 8. The nodes are different. Although the numbers are the same. The value is the same. So they are point to different locations. Here intersects at 2, the node intersection. So let's see some constraints. So the numbers node m n. So the length of two linked lists are greater or equal to 1. So there are no empty linked lists here. And so write a solution with OM plus N runtime and all of N memory. So all of M plus N I all of 1 memory. So basically this is a multiple pass questions in linked list. So multiple pass and so the problem is, how can we know that they intersect? Because maybe they have like different lengths. So the idea is that we cut the length of the long one to make it the same with the short one. and then start comparing each node. So the first step I would do is get the length of two linked lists. And second is cut the long linked list to the same length of the short one. And then there's a while loop to compare each node. So if they are the same, if nodes are the same, return true. Oh no, return the node. Else return or else continue. Oops. Else continue and then return. Oh no, return now. So how to get the length of two linked lists? So probably maybe it's a good thing I just write it down here and so I think the function, like I can write a function like an inner nested function. So I write a function called get length and I pass a head in it, and the length I initialize as 0, and so if head is null, so I'm going to return this. Else while head is not null, so head equals to head next, so traverse to the next node, and length plus equal to 1, and after that I can return length. So there I can get the length. So length A is get length head A. Length B I can get length head B. So so we cut the long linked list to the same length. So how can I know which one is the longest one? It's the longer one. So I think it's a good idea to have a if our statement. So if length A is less than length B, so let's do it like here, like so short, so short length and long length is equal to short length is equal to length A, and long length is equal to length B, and then short head and long head are equal to head A and head B. Else, to copy this and change this a little bit. So else means length A is greater or equal to length B. So the short length should be length B and the long length should be length A. And here, and so here I get, so figure out the short and long length, long list. And after that, I need to cut the long linked list. So while long length is greater than short length, long head will equal to long head dot next. I'm going to traverse it and then cut it. So long length minus equal to 1. So when it breaks out the while loop, the long length and the short length are the same. So we can go to here and do the while loop to compare each node. So while short head and long head, when they are both are not none, I can compare. So if short head is is long head, so they are the same reference, the same memory location. So I'm going to return any one of them short head. So else continue means short head equals to short head dot next head, long head equals to long head dot next. And after the while loop, if nothing happens, I'm going to return it now. I'm going to run it. Yeah, and it works. And so when you go back and see the algorithm here, the solution here, the get length is all of n because it literally goes through every elements in the linked list. So maybe it's all of m and this is all of n runtime. And the while loop is all of m minus n. And this is also all of n. So the whole thing would be all of m plus n. And the space complexity here, as you can see, I only use the length A, length B, and short length, long length, short head, long head. They're all of one space. So so maybe we can also do an example. Yeah, I think that's it for this one. And the example. Well, the example is not that easy to generate. Like yeah, just end it here and let's see you next time.